we need to take another look at the prompting or the auto prompting. And in this video, we're going to be looking at how the images actually come to be. We've created a lot of them, but what's actually happening? Take a look at this guy here. We've got 512 by I think 768 image. We've got two bottles. There's a I asked for a fairy. It's given a girl standing in some lavender inside one of the bottles. Now, how does it get to this? How do we end up with these images? Where do they come from? They look fantastic, but where do they come from? Understand that when we work with Stable Diffusion, every time we start a new image, it begins with something like this. It begins with a gray image. And that gray image will have this kind of quality. It will have some random noise, some random differences in how it looks. That is the starting point for all the images. And when we actually apply the prompts, what we end up with is something that looks we end up with something that looks nothing remotely like a gray slab with some noise on it, like a slab of concrete or something like that. We end up with amazing images. Now, I want to discuss in this video things that are not necessarily to do with the prompts themselves, but more the things that work with the prompts. So I want to give the idea to you that when you create an image, you're like the boss of a business that produces booklets or brochures, and you're running a team of employees who, some of them do design work, some of them prepare paints for printing, some of them actually do printing, some of them put together books after the printing work is done, and then some of them do the kind of the proofreading to ensure that all the stuff is looking good. Now, you are in some ways the maestro, the company boss who is running the image processing inside of Stable Diffusion. And when things go right, you take the credit. When things go wrong, you've got to be the one that fixes it. But how do you actually know when to fix or where to fix the problems when problems do occur? And speaking of problems, take a look at this image here. Look at that. Look at that. There's a lump of wood there, which just lying around kind of randomly. So how do we fix problems when problems occur inside images? Now, the first thing is there are three areas we need to look at where we have some degree of control and interaction with the artificial intelligence that is creating this image. Now, I'm going to very briefly talk about this. Is scary. I'm not going to spend a lot of time here, but what we're looking at here is a diagram that comes from the early days of Latent diffusion or Stable Diffusion, whatever you want to call it. So Stable Diffusion is about a year old, and this is something which discusses the AI that works inside of Stable Diffusion. We've got latent space, which is where a whole bunch of stuff is happening that involves artificial intelligence. We've got what they call conditioning. Here we've got the semantic map, text, representation, images, and pixel space. Normally when we work with graphics in computers, we're working with pixels. We're kind of pushing pixels around inside of Photoshop and using all sorts of parameters to change the image. But here we have a bunch of artificial intelligences working together to produce the images that you want. And you've got some artificial intelligence that will understand what you're telling them, the prompts, some of them that denoise the image, that sort of gray concrete slab type of image that they start off with. They denoise that, they produce the image that we eventually see. All of these artificial intelligences are trained to be among the best at their job, but they are different. They are different entities, and they're not like a human team where everyone talks to each other and has meetings and tries to address problems and tries to achieve the same understanding. The only way that these things can really work together is if you take command of them, if you understand them, take command, and then give them the right instructions. So three very important ways of interacting with the artificial intelligences. We've got the steps inside of the sampler. We've got the CFG scale, and we've also got what's known as clip skip. Now, most of the time when we work with prompts, we're working inside of the positive and the negative prompts. And this is what it looks like inside of the efficient loader and the efficient efficient sampler. The positive and the negative are usually where we spend a lot of time, but you need to really understand how the positive and the negative prompts are interacting with the CFG, the steps, and the clip skip. And that's what we're going to be talking about in this particular video. Now, this image here shows something which is actually being described just by a bunch of negative prompts. So I've said to the software, I don't want text, watermarks, ugly, disgusting, disfigured, or nude. And then I've not put any positive prompt. Yet this particular software, using the Dream Shaper, the Dream Shaper model, has created an image which it thinks is the opposite of all these things. If you eliminate from that noise, from that random gray image, if you eliminate these things in 15 steps, you end up with this. Now, the problem here is what is going on. There's a tree coming out. We've got this little piece of wood lying around, but there's a tree coming out of the hut. So I've said don't do disfigured, but this is definitely disfigured. And what we want to do is to try to fix this image. So if I wanted to fix this image, there are a couple of things I could do. The first thing I could do is to start ranting and raving inside of the prompt, saying, I don't... houses without trees growing out of them, or putting negative prompts, damaged houses or whatever. Let's not do that. Let's be a little bit more precise, and let's figure out the steps, the CFG and the clip skip, how they are going to help us. Now, the steps are set at 15. The CFG is at 5, which is low-ish. It's not super low, but the CFG is looking at the text here, the prompts. And when we produce prompts inside of Stable Diffusion, the software will turn those prompts into what are known as tokens. And it's really those tokens that it's looking at to try to develop the image. Now, the tokens are... It's difficult to explain the tokens and how they actually operate, because it ends up being very technical. But the tokens are a way that the software has of understanding the language. And by understanding the language, it's trying to understand your intentions. So the prompts are very important, but in this situation, we don't have a prompt. So how do we fix this without actually doing more prompt work? Well, we could go to the steps and change the steps value. The steps are doing what sometimes has been described as looking at the negative prompts and taking that gray image and trying to remove anything that is that negative. It's trying to take the positive prompts and trying to make sure that that gray image evolves into something that resembles the positive prompts. And the number of times it does it is determined by the steps value. So that's a simple way of understanding. The CFG scale is how much the sampler should look at the prompts. The higher the CFG scale, it goes up to 100, the more the sampler will look at the prompts. And in this situation, it's only looking at the negative prompts. So what I did, knowing that this particular model is a good model and it doesn't produce weird looking images most of the time, I decided to tackle this by increasing the number of steps. And when we doubled the number of steps to 30, what we ended up with was this. We've got everything that was wrong basically fixed. The weird looking pieces of wood here, the out of place pieces of wood have turned into beautiful bushes. There was this thing here, the roof here was looking a little bit kind of awkward. It's turned into a much neater looking structure. And certainly the tree that was growing out of the hut, that's also been fixed. That's pretty good. And we achieved that just by increasing the number of steps. So when we increase the number of steps, we end up with more of what we actually want based on the ability of the sampler to continually look at the model and ask the model, how do I produce what I've been asked to produce? You're asking the software to use all of its IQ to create the image that you asked for. And the more steps that it takes, the more intelligent the way the software behaves. Now, the CFG remains fairly low, and increasing the CFG wouldn't probably have helped very much because for the reasons I explained, we're not really saying what we want to see. If I wanted to see a beautiful house in the woods and I'd stated that, then maybe increasing the CFG would cause the software to pay more attention to what was happening in the prompts, and maybe would get a better response here without necessarily needing to increase the steps. Whenever you increase the steps, we increase the steps from 15 to 30, we double the amount of time that everything takes. Now this is the next image we're looking at, and all I did there was literally just change the seed. So I changed the noise that the image was looking at in order to produce the image. So initially it produces some houses in the woods and they look kind of okay. And then it produces this beautiful looking vehicle, this really robust looking vehicle, the one kind of vehicle that you would find in a very snowy district. It's amazing how it does that without any real prompting from me. I've just told it what I don't want to see. It's looked at that gray noise and it's produced something that looks pretty awesome. And you could really begin to ask the question, who's doing the genius here? Is it me, or is it the software? Who is doing the genius work? I think this is a fantastic looking image. If we go a little bit further and we reduce the steps to 15, we end up with what looks like a car in the snow. So it's definitely decided, hey, there's going to be a car involved in this. And we increase the steps to 20, and we begin to see something that begins to resemble that vehicle we saw at 30 steps, the one that's designed for moving around in the snow. Now, the only thing we were changing was the number of steps. That was it. We changed the seed, and then we changed the number of steps. What I've done here is to keep everything the same, but reduce the CFG and the steps. The steps have gone down to 1 and the CFG has gone down to 0.5. This means that we're barely paying attention to what's happening here. And the number of steps, just 1. In other words, we've barely moved on from that original gray noisy image. I've added a couple of new words, yellow and blue. And just by adding a couple of new words, we've got yellow and blue happening here. I've also, if we take a look at the previous image, very low steps, very low CFG. I've increased the number of steps and increased the number of the CFG. We've gone back to 5 and we've gone back to 15 steps. Here, what's happened is that I've kept everything the same, but just changed the model. Now, when you are not getting the results that you want, sometimes it makes sense to change the model rather than changing everything else. Just changing the model, keep everything the same, the seed. That could sometimes produce exactly what you're looking for. And that tends to produce the most amount of change when you have a lot of prompts in here. We've just got yellow and blue, and we've changed the model from a Dream Shaper to colorful, and it keeps, roughly speaking, the same sort of design. In other words, what's happening here is most of what's happening is coming from the prompts and also the noise. The noise is having a huge impact on what we actually get. So we've gone back to Dream Shaper here, and what we're going to do here is add another word to the prompt. The word is beautiful. Someone looking at this here would conclude that I'd added the word flower. They wouldn't say, if they were to try to guess what words I'd use to describe this, they would say he used the word flower, blue, and yellow flower, he used sky and clouds. They wouldn't be able to guess the words that I'd actually used to describe this. They wouldn't be able to guess text, watermark, ugly, disgusting, disfigured, nude as the negative prompts. There's an ability for the software to produce images that can't easily be traced back to a specific combination of prompts. And that ability where you get an output that can't readily be replicated by guessing the prompts. That ability is one of the probably most useful abilities when you are working professionally with this software and you don't necessarily want to give away your secrets. So we saw earlier there was a workflow saving option, which I think I've still got here. We can export images without the embedded workflow. So we can do this using this plugin here, this extension. That's one thing you might want to do if you want to keep your prompt secret. I think there are actually good mathematical reasons why we can't completely reproduce the prompts from just looking at the image. Now I want to move on to a different image. I'm going to go down a couple of steps. And we're going to look at this this lighthouse. I've changed the prompt to lighthouse. We're looking at Dream Shaper, the model, the main model, and we're looking at 30 steps and 6 CFG. By my thinking, by my reasoning, this image here looks pretty nice for a 30-step image with a CFG of 6. The colors, the detail, it looks really nice. It's following my instructions. Don't have text, watermark, ugly, all that stuff. Just have a lighthouse. And it's really kind of remarkable how the software can produce a really kind of holistically sensible image just from a single word. It figures out lighthouse, and it also figures out a whole bunch of stuff that go with lighthouse. The colors, keep an eye on the colors. We're going to be looking at the colors. We're going to be looking at the contrast. Here, the colors and the contrast are good. We've got nice, healthy red, white. We've got some contrast. We've got a sort of gray, cloudy sea. Let's move on to the next image. Here, we've kept quite a lot of the parameters the same. So we started off here and we moved on to this image. And all that really changed was just the model. So changing the model just changed the design significantly. This guy here, for whatever reason, looks a little bit more, a little bit less cloudy, a little bit more contrasty in terms of color. There's more color contrast there. What I've done here is reduce the CFG. So I'm keeping everything else the same, but reducing the CFG. So if we do that, notice that everything remains relatively good. Nothing bizarre happens just by reducing the CFG to 3.5. And now what we've done is reduce the steps. We've taken the steps from where they were from 30 down to 1. And when we take the steps down from 30 to 1, we lose the structure. We lose the meaning inside the image. It's almost as though the steps are essential for bringing out meaning inside these images. The color, interestingly, the color is already there. Even at step 1, the color is already there. We've got the blue from the sky. We've got something that begins to look like a White House. That's interesting. One step, we've got something that begins to resemble the final scene. Let's go to 251. Here, what we've done is increase the steps to 2. It's still looking kind of like we don't know exactly what's there, but we've got lots and lots of saturation and lots of contrast, way more saturation and contrast than we started off with. And the main difference here is not the change in the number of steps. The main difference is the change in the CFG. We've gone from about 3.5 to 12.25. And the image has changed drastically just from changing the CFG. More contrast, more color. What we've done here is increase the steps from, I think, 2 to 5. wasn't it? Now that increase in steps from 2 to 5 produces a meaningful image, but we still have this crunchy detail. We still got these amazing colors, although they're not amazing. They're kind of too much. And that happens with just a steps level of 5. When we increase the steps level to 26, things improve, the colors improve, but it's still crunchy. It's still, there's too much going on. There's too much saturation. There's too much contrast. It looks as though the CFG number is what's giving us that saturation, that contrast. Every time that we've seen that saturation and contrast, the CFG has played a role in producing that. Let's go down a bit further. What I've done here is to reduce the CFG, and we see that the contrast, the image, I think now looks a lot better. It loses some of its ugliness. When we increase the CFG to 32, it just becomes horrible. We get lots and lots of contrast. We get lots of horrible colors. There's all sorts of weird detail going on here. Reducing the CFG, reducing the steps, we get something that almost resembles that completely gray image that we start off with. Now, what I'm trying to demonstrate here is how important the steps and the CFG is in producing the image. Remember, the prompts are not changing, and in the last few images, the last 5-10 images, we've not changed the seed or the model. All that we're changing is the steps and the CFG. Increasing the CFG creates even more contrast. We've got 18 now, and the contrast is almost striking. It's almost like the thing that really stands out. We've got dark colors here. We've got very bright skies, very blue skies, very saturated skies, and we've got this contrast even in the sky. Now, what's going on there is that as we change the CFG, the main thing to really take away is the CFG seems to be involved in very high levels of contrast. Low CFG, very low contrast. High CFG, high contrast. And then we increase the steps. That seems to somehow improve the situation. So increasing the steps, even with high CFGs, seems to produce a better outcome. So that's something that's something of a takeaway there. So even when the CFG level is very high, increasing the steps level might actually rescue you. Let's go ahead and go to the next one, which is a very low CFG. We actually kept everything else the same. Absolutely everything else remains the same. And you notice there we have black and white. Now the image, I think, actually looks kind of beautiful. So very low CFG. It looks like a pencil sketch. It looks black and white. I kind of like it. I really like it. I think it looks awesome. But it is black and white. So high CFG, high contrast, low CFG, low contrast, low color. But the low color, as in this, I can't see any color here at all. So it hasn't moved away from that total grayness, except we've got a steps level of 28. So the thing that seems to work to really impact on the saturation, on how much color there is the CFG. No matter the fact that we've got a high steps level, moderately high steps level, we still keep the gray. So the CFG and color are intertwined in a way that is a little bit surprising, but something that you really need to take notice of. And then low CFG, low steps, we end up with that sort of mid-gray color. So hopefully at this stage, you've kind of understood what I'm trying to get at, that the CFG has a big impact on color and contrast. We now have a moderate, fairly low CFG and fairly low number of steps. We're still using the same model, and we've got these nice muted colors. We've got bright red, yes, sure, but we've got fairly muted blues and reasonable contrast, but not excessive contrast. We change the model and things remain roughly the same. the composition remains almost identical. And that's sometimes a really cool feature when you're using just a few words, just a limited number of prompts. So in my experience, when you increase the number of prompts, you tend not to get equal results when you're moving between different models. So all we did there was change the model and it remained the same. What I did there now is, if you take a look at the seed, we go from 24 to 25, and the result is we get a complete change. So changing the noise can radically change. Even one number can radically change the results that gets rendered. And generally speaking, that's the same whether you're dealing with one version of Stable Diffusion or another version of Stable Diffusion. So we move on, and all that we're changing now is the model. So we're moving from Dream Shaper to Skin Rate. Skin Rate is one of my models. It's one that I created, and I created it basically because I really like two different models, but those models would sometimes give me weird results, and when I merged them into a single model, they actually worked a lot better. And Skin Rate was one of those merged models. There was another one as well. Notice that as we move from 9 to 31, that's 9, we get a radical change in the landscape. Now, what the steps are doing, remember, is taking a look at the prompts and taking a look at the CFG as well. They work with the CFG, but they're taking a look at the prompts and they're saying, okay, how do we produce what this guy asked for, given that we have this model as the place to get our inspiration from? So 31 steps, 9 steps. There's a huge change between those two, and then we go up to 55 steps. There's a significant change also from 31 to 55, but the change from 9 to we go from 9 to 31, I think you would agree is a lot more than the change from 31 to 55, and that's something that I generally find to be the case. It's the changes that happen in the low numbers of steps that has the biggest impact on the final image that you see. So from 55 to 31 to 55, we don't get a huge amount of change. We get the windows moving around, and we get this little thing shifting a little bit on the house there, but the lighthouse itself remains roughly the same shape, and we don't get a huge amount of change. So when you go above, say, about 30 with Stable Diffusion 1, things don't change that much, and that's generally speaking been the case. In certain situations where you have a lot of text here, things can continue to change quite a lot. Even above 50, 60, 70, you see very significant changes as you go up to 100, 120. We go down to 22, everything else remains the same. The image is still very usable, even at 22. And then we change from, we keep the steps at 22, we increase the CFG to 10. So we're going from about 4 to 10. And the results of going from 4 to 10, just that one change produces a very different looking result. Somehow, by getting the CFG to pay more attention to our text, to our prompts, we get a really fairly different looking image from the one that we had before. Notice also the colors and the contrast. The colors have become slightly more saturated, and we can zoom in a little bit. And you can see here that we have got more contrast throughout the image, more color, and that's something which usually I find I don't like. I usually don't like this sort of response, this kind of result, but it's a low CFG, it's just 10. CFG of 25, we're beginning to get cartoons. We're beginning to look at what looks like a cartoon. It looks ridiculous, and then when we increase the CFG to 50, remember it goes up all the way to 100. At 50, it looks like a child designed this. Like, it's what I'll call naive. It is so dark that it's had to put a sun there to kind of give the impression that it tries to make things logical, but it's produced such deep shadows. It's actually produced a sunset to justify those deep shadows. And I gotta tell you, even at sunset, I don't think we'd see this color blue. So at 50, the saturation, the contrast, it's off the scale. It's really off the scale. So we did change the steps a little bit, but most of the change there comes from the CFG. And then we have this here where we've got what looks like, it's almost cartoonish in nature, but it looks good. We've got the lighthouse there. We've got another lighthouse. We've got what looks like a rocket taking off here. It looks like a rocket, doesn't it? But it's actually a lighthouse, and it's in the sky, but it looks like one of those spaceships where they're kind of billowing all of this kind of fog and small and cloudy gas that they give off as they launch. Now, why do we have this here? We've got this here because I put lighthouse surreal, which is a form of art, and rocket ship. So I wanted a surrealistic image where we've got a lighthouse that could perhaps be taking off like a rocket. Somehow it figured out that this is what I wanted, and it gave me this image. Now, this one is not a huge difference to what we had before. I've added a couple of words. I've given it a sensible CFG of 8.75, and we've given it steps of 155. That change to the number of steps was what allowed it to produce this really amazing image where we've got something that looks pretty artistic, exactly what I was asking for, something surreal. It's given us something that isn't a rocket ship. It's a lighthouse taking off. We could title this, I don't know, the USS spaceship lighthouse takes off on the horizon in early morning. Now, the reality there is that the software was able to create something that really met all of my expectations, but we got there with a very high steps number. Now, I've tended to emphasize the fact that I like low steps number because when you have a low number of steps, the thing processes quickly. You can get more, you can test more parameters, you can test more prompts, you can test different models. When you finish quickly with the number of steps, it gives you degrees of freedom. But if you want your final image, sometimes I do recommend increasing the number of steps to a very large number, particularly when you're dealing with concepts and ideas that are fairly complicated. And that sometimes will actually give you a better result than you can get at about 30 or 40. And with some models, you can go very high, and some prompts you can go very high and still get significant improvements in the image that gets rendered. Now, the other thing I promised to talk about was the clip skip. Now, clip skip operates on the part of the neural network. It actually operates on what's known as the clip network. And the clip network is a network that analyzes the prompts. It's involved in taking the prompts, taking those, making those into the tokens that the software actually works with when producing your image. Now, the clip skip it's a way of reducing the number of steps that the software goes through when it's trying to understand what you told it. And some people will request or suggest that when you're working with a particular model, for instance, let's say we're working with Dream Shaper. Let's say Dream Shaper suggested with Dream Shaper, you want to work with a clip skip of -2. What that would mean is that with this particular model, if that was the recommendation, the author of this model would not want you to process the speech part, the prompt all the way. The low steps number gave us a surreal image, something that is so bizarre, but which sometimes I didn't put surreal in the box there, but it gave us a surreal looking image. And if you think about it, sometimes what you actually want is not something that's perfect. You want something that is broken, something that is weird, something that maybe is disfigured. So sometimes when you are working, you may want to take some of these negative prompts that I almost always use and transfer them to the positive, because for your type of workflow, these terms might actually be preferable as positives. Sometimes low steps numbers may be positive because things don't look good at low steps number. They look kind of broken. So that's something to consider. It's definitely the case that you tend to find most guides tell you to increase the steps number to get a better result. Think about reducing the steps number to get a better result. Think about reducing the CFG number to get a more gray looking outcome, a more desaturated looking outcome. Do you remember that image with this vehicle, this amazing looking vehicle? See how desaturated it is. We've got a CFG of 5. If the CFG was higher, we'll begin to get weird and unhappy colors that would appear inside of the image. As far as that issue with the CFG scale producing nasty looking results at a fairly low number, well, it's something I think we actually saw a little bit of earlier on, and we saw it with this particular situation, not that one, that one. So we did the comparison earlier on using the XY plots, and do you remember how we got results for the CFG scale of 16? These results are actually more saturated than this guy here. The CFG of 8, to my mind, looks better, and it looks better here. And when we combine a high CFG and the DPM2A, the TPM2 ancestral sampler, we end up with a CFG 16 result that is pretty much unusable. These guys, I could consider there could be potentially some use cases for these two, but in most cases, the 8 level actually looks better. So my recommendation is, when you are working with CFG and you're developing your own workflow, one of the things you want to do is to make use of the XYZ charts. These will tell you at what point your particular designs are beginning to fall apart with the CFG number. Raise the CFG number if you need to. Use these charts to figure out how far you can go with your workflow. If you use DPM2 quite a lot, you may not be able to go very high. If you use Euler here we've got Euler and Euler, you may be able to go a little bit higher with the CFG scale, but be careful, even 16 can produce problems in terms of contrast and color. Now these problems with contrast and color, how can we take care of them? Well, keep the CFG scale number low. My recommendation is, when you need to increase the CFG scale beyond what you can bear in terms of the color saturation and contrast, instead of increasing it more, just go ahead and add more information inside of the prompt. Doing that will allow the software, the clip network, it will allow the software to understand more about what you're trying to say. So I don't know if this is going to work with your workflow, but it's something I've tried. I've tried to put more terms, and this is what I was trying to suggest in the previous video, where we were talking about the Persian princes, the Egyptian princes, lots and lots of terms. Sometimes you need to do that in order for the software to understand what you're trying to achieve. The use of prompts, increasing the number of prompts, changing the prompts so that the meaning is more precise about what you want, changing the prompts so that you include prompts that are not exactly what you want, but which are related to what you want. Sometimes doing that is better than increasing the CFG scale. That's one way of tackling the problem with the CFG scale. So hopefully at this stage, I hope I've persuaded you that there is an issue with the CFG scale when you go above the teens, the mid-teens. And hopefully this has been some useful information for you, because I think some of these issues, they're not just found with Stable Diffusion 1.5. You find them with other versions of Stable Diffusion, and they're really to do with how the software actually interacts. It's to do with deep issues within the software design. Now, one of the other things that might become a possibility for you. It depends on how much time you want to do this. But if you open up the manager and we go into custom nodes, there's actually a couple of very interesting extensions. These I think come from Stability AI, but there are two extensions here. One is called ComfyUI Experiments Sampler Tone Map, and the other one is Experiments Sampler Rescale CFG. And these two are really designed to try to tackle some of the problems that we are looking at in terms of the way the CFG produces too much saturation and too much contrast. So hopefully I've demonstrated that it is a problem, but hopefully also you now understand that other people have found issues with the CFG. There's actually a very interesting link in one of those custom nodes to a paper that was produced by of all groups, the guys over at ByteDance, and it's a very recent paper that describes some of the problems with the CFG scale. And it's actually called Common Diffusion Noise Set Schedules and Sample Steps Are Flawed. It actually suggests that there is the way that we use CFG might actually be broken, and they make a case for that, and they make a case for what they think might be a solution, and that particular argument has been taken into account in one of the new extensions. Now these are experiments, they're experimental, but you're free to install them and to experiment with them. When I was using them, I actually kind of liked them. I actually thought that they did a lot of good. So hopefully we may see some improvements coming along sometime in terms of how the CFG works. But otherwise, try to keep the CFG safely low. Experiment with steps that are low, experiment with steps that are high, and be aware when you bring in workflows from other people, from other users, sometimes you'll find the clip skip has been set to minus numbers that are a little bit lower than perhaps is ideal for your workflow. So you may want to change that. And finally, make lots and lots of use of XY plots to understand what impact the steps are having, and also to try to avoid too much damage from the CFG, from the use of CFG numbers that are too high. Understand also where the CFG numbers begin to introduce maybe lack of saturation and lack of contrast that might damage the outcome of your prompts and your designs.